I wish that you would come and give me something to prove. Won't you pull me closer? I think that I'm obsessed with everything that you do. I'm waiting, trying to be patient. You look like a painting. It's so frustrating. I hate it, yeah. I probably shouldn't say this. I probably should erase it. I probably.
Okay, Vivin Sensei,
Okay.
5 minutes.
Okay, thank you very much. Selamat siang, konnichiwa, minasan. Yeah. So good afternoon, maybe. Okay, so now I will speak about. This is my turn to speak about the analytical technology for environmental studies. Yeah. So we start from here. So I think you can read this one. This is from Long and Fox. Yeah. This is 1996. They mentioned that the earth enables our people to survive. The environment must be respected and maintained. As long as the earth remains healthy, the people remain healthy. So I think all of you agree with this one. Yeah. So okay, I saw some of you say yes. Yeah. So thank you very much. Yeah. Okay, I will continue. What is the environmental science in this case? Yeah. So now we must understand about this one first. It's mean we would like to study about how human interact with their environment. Yeah. And then also here, we must concern about everything. Yeah. That that's surrounding us, both natural and man-made. Yeah. About the car, about what is it? Field like golf field, golf yard, or maybe soccer field, and also establishing some university in one place. Yeah, so we must know, and also set some settlement, or of course the other like manufacture or some amusement. Yeah, even though like what is it? Like we are going to establish Jurassic Park. Yeah, it's kind of amusement for someone, yeah, who interested with the Jurassic period, yeah, and they will construct this one. So of course they must consider about a lot of things, yeah. Okay. Oh, I cannot move this one. Okay. So the total of our surrounding must be our concern, yeah. So like living things, animal, plants, forests, yeah. Even though you find some fungi, yeah, also, yeah, and then non-living things like continents, oceans. So just now we heard someone have some argument why marine debris come from here. We must consider about this one, yeah, about our continent, our island also. So therefore we can make some decision. We can sit together with someone from other side, yeah, to decide something. Also like building human create living center, yeah, and this is social relationship and institution. This is very important. So because we need some communication. Sometimes if we have a very worse relationship, the simple thing cannot be solved, yeah. The simple thing, and then we cannot find out how to overcome the simple thing if we have some bad relationship. So therefore we must maintain about this one. Okay, this is good, yeah, in one case, yeah, but if we under control, of course, this is also have some effect to the human. Yeah, crude oil, natural gas, coal, agriculture crop, fresh water. When I was master degree in Philippines, on the time I would like to say that paddy field is very important. So our government would like to open a deforestation, yeah, to cut the forest, and then we would like to think about the agricultural crops. So, but some of researcher, yeah, from the IRRI, yeah, actually he is from Europe, but he works in Philippines on the time. make some protest about this one, because we make some deforestation, we cut many forests and make paddy field, yeah, and then we also use many kind of the fertilizer, and this kind of process also we release to the environment, yeah. They prove about this kind of situation. And also, yeah, this kind of renewable resources, non-renewable resources, this is we must be considered, yeah, for the human. Then you must see also about the ecological footprint. It's a kind of method to measure human demand on natural capital, yeah. So you can see here, yeah, the difference between this, the environmental impact of the person or population. So amount of biological productive land plus water for raw material and the dispose and recycle waste must be considered. So here, you know, that we are using now 30% more of the planet resources. Then let's see I think you can see the meaning of this one, yeah, footprint. Here we established this one, but we already sacrificed several things here, yeah. So therefore, please see here, yeah. There's some different, yeah. The ecological footprint are not all equal, yeah. So don't make some. I would like to know. So don't make some the average approachment in this case, because if we compare people from United States, Mexico, Ethiopia, China, India, Rwanda, Indonesia, also Israel, yeah, France. So the look like here, the U.S. footprint is almost 5 times greater than the world average, and developing countries have much smaller footprint than developed, yeah, country. So therefore, if we would like to make some approach to about our regulation, about the rules, so we must consider about this thing, yeah. Also, anyway, this is just kind of the introduction first. So now also we face challenging in agriculture also, yeah, increased population and consumption. This is we must expand food production, yeah, and also humanity's greatest achievement, but there's an enormous environmental cost, yeah. We open, for example, soybean, yeah, to produce the oil, but we must also there is some what opportunity cost that we must pay, yeah. Nearly half of the planet land surface is used for agriculture, yeah. So therefore, from here we have some consequence, yeah. We must consider about chemical fertilizer, pesticide, erosion, change natural system, yeah. I think logically, someone who interested with nature, yeah, with the environment, you can directly understand about the situation. And also pollution, yeah, waste product and artificial chemical use in farm, industry, and household, yeah. Don't think that farm and industry are just as the source of pollution. Household also, yeah, household, yeah. Sometimes it could be, but yeah, it's still rare, I think, some information, but in specific place, I think they have some this kind of data, yeah. So this is some reports of million of people die from pollution, yeah, but sometimes they just ignore, yeah. And here, challenges in climate, yeah, also some happen. So maybe in the first pages, I forget about sometimes when I attend kind of the environmental seminar. So on the time, yeah, I was still 26 years old. I always concerned about the global warming, yeah, on the time, yeah, in Tokyo University about 1999, yeah, 1999. I was there. So one researcher from the North part area, yeah, they will also concerned, please don't always think about global warming. Can you consider about the global freezing? Yeah, this is also happen, but people always think about global warming because maybe many people live in the hot area, yeah, in the equator, or maybe some temperature. Sorry. Okay, so like this, yeah. Then here, since the industrial atmospheric carbon dioxide concentrate have risen 50% highest level in after 650 years. So here, if you say that I don't eat this kind of grass, so you didn't consider about this one, but this grass actually absorb kind of the chemical, yeah, from the land, or maybe from what is it, from the sea, yeah, that already contain the residue, yeah, whatever this kind of chemical, yeah, also maybe some related with the plastic, yeah, in this case, yeah, because I learned also plastic stopper when I was a doctor degree. So maybe they accumulate in this what is it, plantation, or maybe some crop, and one day you also they will accumulation in your body. Yeah. Technology reduce pollution. So no many kind of the information. I think when maybe 3 decades ago, I didn't see some product with label E. Yeah, no, there's some what is it, E something in front of the some product. Yeah, so maybe you understand about the E in this case. Yeah, and then biodiversity protect species, waste disposal, recycling, and alternative fuel. So this is, yeah. So this is also like how can human live within the planet means. So I think Japan already what is it, make some progress with this one. They don't want to do this one because when there's some hurricane come, so or typhoon, so maybe it must be stopped. So now how to solve this problem? So they already produce something that may be different with this kind of system. So one day maybe if you are a decision maker, you must consider about this one also. So in this case, sustainability lives a future generation with a rich and full earth, conserve the earth natural resources, maintain fully functioning ecology system, yeah, like that. So now we have time to take a rest, yeah. Sorry, I already corrupt the time for a minute. Thank you very much. Next, I will continue the second term, yeah, for my lecture. Okay.
Thank you, sir.
Okay, so okay, take a rest.
Okay.
Raman Spectroscopy for environmental analysis, yeah, like this. Okay, so, wait a moment. We use our eyes, okay, directly, naked eyes. Or if it is far away, we use kind of the telescope like this, yeah. And if it's very small, yeah, we need kind of the microscope. This is long ago, yeah. But now, starting from 2000, we just use laser and we can understand some changing inside. Here, maybe I think I can say destruction. Here, oh, we can see something there and pick up an observation. So in 1990, maybe until now also in some countries, so they also observe to make like this one, yeah. In my laboratory also, we still do this one, but this kind of effort just for clarification to support our data using laser. Okay, can you get it? So even though we work in laser using laser, yeah, to understand something, we must make some confirmation before we release this kind of information to the society. Yeah, we still use, yeah, but one day it's enough using this one. I would like to share with you maybe I would like to say that long ago, each time we would like to publish kind of the biology molecular data, they must be supported by very, I can say not yeah, like with histology data, yeah, or maybe like immunohistochemistry data and morphology data. We use this one to support biology molecular, but no, biology molecular already developed, so they use just biology molecular. In case of Raman system or laser study also, we still use some clarification data to publish a kind of the result, yeah. Someone, C.V. Raman, first described Raman scattering effect, yeah. It starts from here, so he got a Nobel Prize, yeah. This is the timeline of the Raman system. Yeah, actually, Mr. Raman is from India, but he took school in United Kingdom and produced a kind of the very valuable equipment devices, yeah, or system laser, yeah. So in the 1950, yeah, and then they also developed, because also there's some weakness of the system, so they developed a lot of things like this is Raman microscopy, because we need microscopy. So they combine Raman system, Raman effect with microscopy, and also there's something that disadvantages about this one, so they develop again with the other thing like using tip enhanced Raman spectroscopy. Yeah, in this case, to enhance Raman signal, because here very weak, and we use something. Yeah, so but in case of me, I focus using Raman microscopy because I'm not I don't want to say that I'm spectroscopist, because my background actually, I was on the time study about animal science, yeah, wildlife, and then study about the veterinarian, yeah, about cell, yeah. Then now I support and study about Raman microscopy, yeah. So therefore, please don't blame one day and also, oh, I think it is not for me, yeah, something like that, because yeah, actually we are going to develop kind of the technology to make it simple in the future and very easy, yeah. Please keep this kind of message from me. And then faster producing data, yeah. I can say that, but you are student now, you come here, you must study why it is very fast. But actually, I would like to say that we just need 1 minute and we have the data, yeah, directly, yeah. So you can understand one day if you would like to make some implementation here, you have this equipment, then you come to the market, you would like to know whether this fish already, already preserved with formalin or not, you can directly on that time. Can you imagine if there's no such kind of the technology? So, I mean, yeah, I don't know, police or maybe with certain department from agriculture, or come to the market, yeah, pick up the sample and bring to the lab, and tomorrow come again, hey, your product already contaminated with formalin. To whom this officer will speak? Maybe this someone who sell this already escaped on that time. Yeah, one day before. So when you pick up the sample, and I think this kind of the trader already have some mistake, maybe use formalin or maybe borax and the other thing, yeah, or maybe chlorine, yeah, to make, in the tropical country, many kind of product, it's a little bit very easy to be rotten. So they use something maybe, so therefore we can detect on the spot on the time, yeah. Because, and then also this is with the preparation. And then potential to observe sample with low cost. Because just like, yeah, directly. Yeah, of course, for a while now, this equipment is still expensive, but one day, yeah, you know that this is 21st century later on, so maybe many kind of this product, this equipment in the market, and people understand how to use this one, yeah. So therefore, I will shift again. So this is the inspiration. Yeah? Laser set cell aglow for biopsy without the knife. Honestly, I would like to say, so I graduated from doctor PhD 2004. I read news about this one, only like this, yeah, because it's not my field actually, spectroscopies, yeah. But one day, 2008, yeah, I have chance. Yeah, I continue postdoc on the time, yeah, using conventional method. I have chance to meet with Professor Hidetoshi from the Rikeng. So Rikeng is kind of like Puspitek or maybe LIPI in Indonesia, yeah, like something like that. So I try join with them, yeah, and I saw that I didn't have some skill about spectroscopies, but but the question now, why I can join? Is it very important? I think, yeah, because I read very carefully about the the qualification for someone who would like to support him. First, someone who familiar with spectroscopies. Second, someone who can handle animal. Someone, I forget the other thing, yeah. If you have some skill, one of them, yeah, you can apply. So, because I have some skill to handle the animal, yeah, and I'm also interested with this technology, and I offer myself, and I come to him, and yeah, success. And I started studying about the spectroscopies, and then I developed something, yeah. So what is Raman spectroscopies? This is very important. Raman spectroscopies, this is the fundamental of Raman effect, yeah. Imagine that this is incident beam with some energy, yeah. So this is one place like this, yeah. There's a 0, 1, 2, 3, 4, yeah. So this kind of the, vibration, yeah. So we can relate scattering if there is no, plus and minus energy. So when beam release like this until the virtual state, and they also will come here again. So this will be 0, yeah. If we must make some Raman scattering, it will be like this one, yeah, here. There's no positive. So before continuing to explain this one, let's see. This is kind of the molecule, yeah. Maybe I must change the option pointer with a laser pointer, maybe like this. Okay. Can you see the laser red? Yeah. So if there's some energy beam like this, look, the molecule will have some behavior like this, and then spectrometer can read like this. Yeah. So this is the relay scattering. Yeah. So we see the Raman scattering, yeah. Relay scattering will be like this in 0, yeah. So there's no, but when there is some difference or gap, yeah, there's positive and minus. In case of this one, you see, yeah, come to here, yeah, and here. There's a stock sketching, so minus, yeah. So this is, I just want to, yeah, I think can you see my video?
No, sir.
I mean, my
Your camera?
yeah.
Okay. Already on.
So this is mean symmetric like this, but when they like this, yeah, this is asymmetric, yeah. This kind of this is the longer, this is the lower one, and then the deformation mode, this is kind of stretching, yeah, like this and some like this, yeah. But here, like scissoring, yeah, like this, and this is tracing like this, yeah. So, and many actually, yeah. I just demonstrate some of them, yeah. So this is the molecule will react because of some beam or some energy come to this kind of molecule, yeah. So this is the demonstrate. For example, what is Raman spectrum? This is cholesterol OLED, yeah. Laser come like this, yeah. Raman scatter light, and then we have they convert, yeah, and we can see this is the, for example, setting mode of ester bonding for the chemical. So they will have some peak like this, yeah, and also here peak like this. And sometimes, but for biology, for example, if you would like to study sample that it is from marine biota, also you maybe in this part, yeah. Sometimes also you must see the other part here, yeah. But at least now my experiences, I always set up until 200 until 1,800 1,100 nanometer, yeah. This is laser, Raman spectroscopy laser, and this is the sample, yeah. Look, laser come and here, so they are this kind of the reflection contain Raman scattering stroke and Raman scattering anti-stroke, yeah. So this is, we don't need to make some sample preparation directly. You would like to observe here. This is as small as the size of focal point. Then you can have the data. Advantages of Raman experimental. Wait a moment, someone access. Okay. Gabriel number 1, Hikara Harada 1, Jariang 1. Okay. We currently have our product tested by an outside lab, so we can check, yeah. Look, yeah, now in the society like we currently 80%, yeah. This is 4%, and we plan to start testing in the near future 44%, and we probably not have the need for this testing 34%. You see, we will probably not have a need for this testing also 34%. So this is the current society concern about this kind of work. Okay, so in case of you, just now you select number 1. Yeah, so you can understand your position in this case. Okay, we'll continue. Using the result, so this is typical data, yeah, number of particle per sample. So this is the group particle into size. You can see the size. I think similar. This is chemical identification. FTIR like this one, yeah. Compare the reference sample. Like maybe you can directly to see one paper already published by Dr. Teja, yeah. This is automatic analysis like this, yeah. You can see the sample and then observe the data, micro FTIR, so you can identify what kind of the material is it, yeah. Combining all the data also, yeah. You can make some plastic identification by FTIR, yeah. Determine source contamination and improve bottling or packaging process. This is kind of the solution for this kind of the work. This is paper you can study in 2019 also, that from the inhalation monitoring phthalate exposure in human, yeah, inhalation also. So please be careful, don't burn plastic, yeah. And also please be careful, yeah, about this one, the car, yeah, about the lung of phthalate concentration due to inhalation exposure like this. I just skip. This is group 1 of pollute air inside the car. Yeah, so this is also, we must be careful. Physical interior have dangerous level of toxic chemical, mainly from flame retardant and plastic softener. And also here, the this ecology center also reveal new information about toxic chemical exposure in automobile interior. So therefore, maybe it's better if you would like to sleep outside the the car, yeah. Then even though you have some air condition. So here, driver and passenger are exposed through inhalation and contact with dust. Yeah, this is also have some consequences like birth defect, impaired learning, liver toxicity. Yeah, you can you can explore this information from this homepage. Yeah, and then here also most people think about car causing outdoor air pollution such as smokes. Yeah, so this is since automobile have interior car. 360-degree window surrounding, so there's some possibility you will have a temperature like this, yeah. And also some UV exposure from parking in the sun create a favorable environmental for chemical breakdown, and this is also causing like this one. And also solar exposure in car can be 5 times higher than in home and office according to the study, yeah. So the ecology center also already release kind of the information, yeah, from 2000 until 2005. They make some study, and model car made by 11 leading automotive manufacturers. So they inform like Volvo was found to have the lowest level phthalate at the second lowest level of this kind of. This is the data, yeah. Oh, sorry, I make mistake about. This is ranking of vehicle, yeah. Concentrated Hyundai, Volvo, BMW, Honda, Ford, General Motors, Toyota, Honda, and the other thing, and you can compare, yeah, about this kind of contain what is it, a total phthalate per milligram per meter cubic, yeah. So you can check. So this is kind of the.
Yes, sir.
Okay, so we finished. So we still have 20. We will start preparation for seminar 16:30. Yeah, we still have 15 minutes. Yeah, to have. Okay, maybe next we have a race today. Take a race. Okay. Thank you very much.
Thank you, sir.
Okay,
Yes, sir.
we can continue next. They also need to student, yeah, at least, yeah, to support this kind of information. You must speak about what the history and the schematic of this one, and then the beneficial commercial information of those devices that are available in internet. Please find out FDIR is produced by this company, and available in Singapore or maybe in Germany or in Japan or maybe in Indonesia also. You can buy this one, and can Raman Spectroscopy also, and TEM, yeah, and available of this equipment in Indonesia or Japan and other country, yeah. Please you, so if you have some references, it must be supported. So maybe two students will speak about this one. Please decide, yeah. One student try to find out the background problem and goal. I think, yeah, you will. Yeah, I think you need not so many time to do this one. I think so. This is also number 2, and number 3. Yeah, also some students have will have some tasks. Any other tool can be used, or other researchers have been conducted for similar purposes. Yeah, so but you must inform to us the advantages and disadvantages among them. Yeah. Yeah, for example, someone use TEM and the other use just microscope, and is this enough? So explain about that one. Yeah, maybe the student can have this the 3rd year, and maybe some of you already start from 4th year. Yeah, maybe 3rd year and the 4th year student have this kind of experience and can share to the young one. Yeah, I mean, yeah, you can decide by yourself. If you know, you just ask to someone who are from the 1st year, start here, just identify, yeah, which one the background problem, and express to us next in the presentation, maybe 3 weeks later on. You still have a lot of time, I think. Yeah, read one paper, just one paper. It's very simple actually. Yeah. For one, before I continue this one, any question? Any question from your side, please? Do you understand with my explanation or with this kind of information? Hello?
Yeah, I'm
Yes, sir, I understand so far.
Thank you very much if you understand about this one, okay? Thank you, but I will give you time. So if you have some question once I visit your breakout room, yeah, please please ask me. For example, if I visit group 1, maybe someone since this is FTI error, so maybe you can browsing on internet, blah blah blah, and then Raman Spectroscopy, and roughly also maybe I will explain about something, yeah, that you cannot understand during these 2 hours, yeah, later on. So please you explore, and then I think if you understand about this one, maybe I will I will make a breakout room. Please you access, but give me a time to prepare to send by email the paper that I already decided. Okay, I will send directly to you. Yeah, maybe sorry, maybe is it possible directly to send a file? Anyone have some experiences that we can send the file using the chat? Is it possible we send the file via the chat?
I think it's possible, sir. If it's
Okay,
a document file.
sorry, I didn't make this one before. Okay, wait a minute. This is my seminar, yeah, and then number 2, this one. Okay. Then, okay. Can you see? Hello, everybody.
Yes.
Can you see my? I sent to you the what is it? Just now, make some presentation as. So I already convert this one to PDF. Yeah, from PowerPoint. I think you can see. Yeah.
Yeah.
A little bit big. So this is 10 microbyte, and the other is 10 megabyte. Yeah. Megabyte. So maybe I must go to the room 1 again, because some of them cannot receive this one. But before I leave, but I will come again. Yeah. Anyone would like to ask something about your task?
Uh, I want to ask actually, you mentioned before that we are talking or presenting this topic based on single paper you have shared, right?
Yes.
So I want to ask which topic that need other references, other references other than the paper that you've shared. Like
Yeah.
maybe the research overview would be like based on your paper, almost just based on your paper, right? But the other.
Okay, hello everyone. I'm the new leader here. I hope we can work together in this topic because I think this topic is not that simple, and we all know that. So there is four topic here, and the first one is what is background, problem, and goal of this research, and is there anyone want to take this topic as their presentation on the next material? It's just one student, yeah.
And Geoff, I think you have to consider what Professor Bibin have said before. Maybe for the topic that are pretty easy should be given to first or second year student. I mean, it could be anyone, but yeah, prioritize the first and second year student.
Okay, then is there anyone who is not second year here? Beside Kak Wilandari and Kak Timo, ya. And this for the second topic. It's about what is VTER for group 1, ya. Stories, semantic debate.
Oh, how is sir?
Hello.
Hello, sir.
Okay. So,
Sir.
Hello. Can I ask a question?
okay, please.
So I'm sorry if I didn't hear it clearly before, but I want to know if we can add more references to the presentation beside the paper you give to us.
Yeah, you can do this one. Therefore, I gave it what is it paper, because once you shift to the last part of this paper, there's some list of references. Yeah, you can explore from there also. Okay, and of course, not only references. If there is some news also, sometimes in commercial things faster than paper. It could be happen. Yeah, because I would like to share with you. Yeah, if there's some company have some collaboration with the university never want to publish paper first, because a company support this kind of work, and very important, they would like to have a patent. Yeah, this is kind of the edition information for you, and they have patent and release to the market. Then one day they have some publication release to the international paper. Yeah, because you must understand, you cannot make patent. Patent. If you cannot find out this one in the internet, you just use references that this author already submit its paper. It's very easy there. I just want to give some maybe here I recognize that Yang Yingjiang, yeah, this is the first year. So maybe if I think the first year maybe still have some yeah. But if he would like to do, it's okay. Because in the group one, I suggest to them maybe for there's the task is maybe for 1, 2, 3, 4. Yeah, the number one just to mention about just to indicate which one it is categorized as the background goal and I forget. Yeah, so maybe this the first year student will cover this one. I will cover this one. But if the young Jinjiang said that no, it's no problem. I would like to do this, even though I must speak about the other number. So it's depend on you. It's up to you. Can you get my explanation? Do you understand?
Yes.
Okay. So please, you distribute who will be cover this topic, who will cover this topic, the other topic. Okay? Who is the leader in this group? No?
Hariru, sir.
Yeah?
Hariru.
It's me. I'll
Oh,
be the group leader.
okay. Hareru. Yeah. Oh, second year. Okay. Okay, Hareru, please you lead your group. Yeah.
Okay,
Okay.
I'll do my best.
Okay, thank you. Okay, I will move to the other group.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay. Please, I will go to 3. Hello. If you prefer to study about transmission electron viscoscope, yeah. Hello.
Yes.
Yeah. Yeah. This is just you can discuss and also I will share information.
Job, I think it's already. Oh, sorry.
It's okay. Sir, can I ask a question?
Someone would like to ask me?
Yes.
Okay. Please.
Actually, I'm kind of interested in uh, master degree.
Yeah.
But is it really have to be, if I want to continue the master degree, is it really have to be related to my
Okay.
Yes, no. 6:10 now, already finished.
Okay.
So Sensei, can you
Hey.
close?
Yeah. Okay. Okay. Thank you very much for Bibin Sensei. Bibin Sensei. The next lecture will be held in 2 weeks. So on the 21st of August, it is because we Japanese have a special holiday next week. It is considered that the spirits of our ancestors and their relatives will come back to us on the 15th of August. So family will get together on the day to welcome them. That is the reason why we will skip next week. Anyway, see you on the 21st of August. Stay healthy. So, sampai jumpa lagi. Jaga dirimu baik-baik. Yeah. Bye-bye. Dadah.
Bye.
Thank you,
Bye.
Professor.
Thank you.
Good evening.
See you, everyone.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. So bye-bye.
Thank you, sir.
So I will close.
Yeah, okay. So good morning, everybody. Selamat pagi semuanya. And today is the final day. And today you will give a full presentation, Bibin Sensei,
Yes.
for presentations. So good luck. And the first presentation is about the analytical technology of environmental studies. So which group has a full member currently?
So, well, thank you very much. Today, we are going to start with final presentation. This is, yeah, from my lecture. Yeah, this is our turn to present. So therefore, I would like to let group 1 to start your presentation. Yeah.
So, good morning for everyone. Today, this morning, Group 1 would like to present about analytical technology for environmental studies, and in the particular about FTIR. And then, first, before we would like to introduce our member. There are 9 persons, which unfortunately one of them, Jovita Laraseti Putri, couldn't attend here this morning. And there are Putu Wilandari, Echa Aryunisa, Abelia Oksana, Ana Agung Ole, and then there are Kawasaki Kai, Hikari Harada, Shogoshiro Oyama, and me myself, Timothy. So, first one, Shogo, please continue.
Hi, I'm Shao Shorema. My slide is overview of research. Next. In recent years, the use of plastic has increased, which is in line with plastic pollution. Among them, microplastics are widely distributed from land to the open sea. Today, microplastics of land are 23 times more common than in the ocean. And now there is interest in the ability of microplastics in water to absorb compounds containing heavy metals. Although it has been proven that microplastics can act as a medium for heavy metals, so the mechanism behind this is still unknown. So, in order to find out if this absorption changes depending on the environment and what the mechanism is, our research focuses on the absorption of heavy metals by microplastics in the Musi River in Indonesia and its impact on the environment. Thank you.
Thank you for the time. I will continue to presenting about the history and the schematic of FTIR. History of the FTIR. The FTIR came from the IR infrared spectrum that was found in the 1018. The IR spectrum was discovered by Sir William Herschel, and a scientist named Peter Figot had obtained the first IR spectrum by using the FTIR in 1949. Next. In the process of instrument analysis, the sample include the source, interferometer, sample, detector, computer, and the spectrum. The infrared energy emitted from a lit black body. This amount beams through the metal which control the energy imparted to the sample. And the light enter the interferometer, spectrum coding take the place, then the signal is generated from the interferogram. The beam enter the sample compartment with where it's carried through the mirror or the sample surface depending on the type of analysis. The beam finally passes to the detector to the final measurement, and this detector is used specifically to measure spatial interferogram rays. The detector used in the Fourier transform infrared spectrophotometer is teraglycerin sulfate, TGS, or mercury cadmium telluride, MCT. The MCT detector are more widely used because they have several advantages over the TGS detector. They provide a good response at high modulation frequencies, are more sensitive, are faster, are not affected by the temperature, are highly selective on vibration energy received from the more radiation. And the computer measures digitally and send the computer to be processed by the Fourier transformation. The spectrum is presented for the further interpretation.
On this slide, I will explain about other tools can be used to absorption the heavy metal in microplastic. The tool is UV phase spectroscopy. UV phase spectroscopy is type of absorption spectroscopy in which light of ultraviolet region 200 to 400 nanometer is absorbed by the molecule, and UV phase spectroscopy involves a amount of electronic energy in the molecules being analyzed. And advantage of UV spectroscopy first is can be used to analyze many organic and inorganic substance, and analyze can be carried out quickly and precisely, and can be used to determine very small quantities of substance, and the result obtained are quite accurate, where the numbers that are read are directly recorded by the detector and print in the form of digital number of graphs that have been regressed. Thank you.
Okay, and I would like to tell you about the method, the summary of the method the writer of the study used. First one, as Shogo has said in the beginning, that this research, this study are being done at the Musi River in South Sumatra, Indonesia, particularly at the coastal plain area. There are 10 stations that could be seen in the left side map. These 10 stations are diverse on all the river, and then the sample of microplastic itself was collected on ebb tide period for river maximum load. And so for the sample collection itself, the creator used Newton net, the image only for illustration, not the real image which the creator used. These Newton net are for microplastic samples, operated horizontally 15 minutes, and then it did 3 repetitions for 1 till 2 knots boat speed. Then all of the microplastic that are collected from this net then transferred into the previously sterilized receiver. And then for the water sample, they use Nansen water sampler that operated 20 centimeter below the surface. And then all the sample that has been collected would be contained in the HDPE bottle that has been pre-sterilized and then sealed with parafilm. And for the water's pH, they use HANA portable equipment, and for the water salinity, they use Sontec Castaway CTD. And for the laboratory procedure, there are quite much. For the microplastic extraction itself, they use floating method. In this method, they shifted an NaCl with 1.2 gram per centimeter solution filled to the Andelon Mayer. And then the FTIR are equipped with diamond crystal ATR with a single reflection mode range with 600 and 3,800 centimeters with 22 scans per analysis, and then the resolution itself are 8 centimeter. For the PB and the cuprum analysis, they use wet digestion method, and for the PB and CO absorption, they use model, one dimension model, isotherm model. 2 model are used, which is Freundlich model and Langmuir model. The Freundlich model itself assume heterogeneous surface of the microplastic, and for the Langmuir, they assume homogeneous and monolayer surface. For the Freundlich model itself, the KF are stated to be the absorption capacity, and then the CE are for the equilibrium concentration of metal ion in the solution that are being run, and then the QE are the amount of the metal that has been absorbed. And for the Langmuir model itself, the KL are actually the Langmuir constant, and the QM are the maximum absorption capacity of the microplastic. And at the end, they do statistical analysis. They use 2 different tests, which is the one-way ANOVA and then 2 key tests.
Okay, here is the type of microplastic polymers. And the type of microplastic polymers was identified to ensure that the samples were microplastic. And based on the FTIR analysis, there are 5 types of polymers, which is PAS or polyester, PP or polypropylene, PA or polyethylene, PVC or polyphenyl chloride, and nylon observed. The concentration of PB and Cu in the Musi River surface water vary in all stations. The average of concentration of PB was 0.0347 milligram per -1, while the lowest is 0.0211 milligram. Was observed at station 9 at the highest. It is 0.066 and 7 milligram at station 1, and the average concentration of Cu was 0.0138 milligram, while the lowest was found at station 2 and the highest is at station 3.
Okay. I'll next explain the result data of lead and copper in microplastics and its absorption isosum. Next, please. The figure on the right shows the average concentration of lead, light blue color, and copper, deep blue, in Musi River. Okay. The absorption process of PB and Cu in microplastic surfaces were examined through 1D modeling. It was researched by using the Friedrich and Langer models. And it was turned out to be the Friedrich model is more suitable for materials adsorption on microplastics than Langer based on the R2 data.
I will tell you about 2 beneficial results to society from this research. Next, please. Firstly, based on the FTIR analysis, there were 5 types of polymers observed from Musi River. The highest to the lowest percentage was PP, PE, PES, PVC, and nylon. PP usually found in the surface water because it is easy to float and widely used in manufacturing processes. Other sources of PP in the aquatic environment are food package ropes, bottle caps, and nets. Therefore, in order to clean the river, it is considered effective to take measures against PP, which is the most common source of pollution. Also, number 10 station in upstream was below the umbrella bridge, that icon of South Sumatra province. In this area, there are the largest traditional market and the center for tourism activities. Therefore, the result of this experiment can encourage measures to reduce the number of food packages on the market and regulate littering in tourism.
Okay, I think that's all that Group 1 could explain about this particular topic. I'm sorry for any misconduct or on words or any action. And thank you. And if you have any question, please ask away.
Okay, thank you very much to Timothy Sang. So I will let to the audience, group 2 and to group 3 directly you can ask, and then directly also group 1 to answer. Okay, please. Who will ask?
Sir.
Okay.
Yeah.
Let me know.
Is it the
Yeah,
advantages or disadvantages?
The advantages. Next one, please. Next one, team. Yeah. No. Yeah. Next one. Again. Yeah. Thank you, team. Maybe I want to ask for the disadvantages number 2 can only be used in the ultraviolet region whose wavelength is more than 185. My question is 185 I want to ask uh, I don't know what X5 is that wavelength in micrometer, millimeter, in centimeter, or what else. So I still didn't understand about the one more than one X5 also. Maybe my first question is that.
Okay, I would like to answer.
Yeah.
I'm sorry. I think we missed this one. It's actually 185 on nanometer. If I'm not wrong, I'm sorry. We missed on this one to add the nanometer.
Yeah. Maybe the next one is I want to know for the analysis use UIV spectroscopy for the measure time. Is they take a long time to find the analysis with these tools or take a short time? Maybe that's my second question.
On I will answer the question on UV spectroscopy have a long time to analysis. A long time to qualitative analysis.
Oh, okay. Okay, sir. Maybe that's my question first. Maybe later, if I have any question, maybe I will ask again, sir.
The other question, any other question?
May I ask a question, sir?
Okay, directly.
Okay, so in this group, they are comparing UVVIS spectroscopy and FTIR spectroscopy. So I want to know, in your opinion, if you have to do an analysis, which tool would you like to use? Or is it dependent on the type of molecules and techniques to choose one of the tool to use in your analysis?
Okay. I will answer the question. In my opinion, I think FTIR spectroscopy is better used in analyze because need can be used in various phase like gas, solid, or and other. While a UPV spectroscopy has a weakness in qualitative analysis because the analysis not too raw. Thank you.
So I just want to tell you, yeah, to inform you. So therefore, why I set up FTIR, Raman, and also what is it, PEM, yeah. You know that before we analyze something, we must see something. So therefore, now we use microscope, yeah, light microscope, and combine with the FTIR and combine with Raman, and we can see. But unfortunately, the magnification only 1000, yeah, if the objective lens is 100 times multiplied by ocular with 10 times, so only 1000 magnification, yeah. So therefore, when we can see, and then we use the laser and directly we observe our sample, so we understand the biochemical content of this our target, yeah. So using FTIR and Raman. But if we speak about FTIR and Raman, of course, some advantages about of them they have. So, but FTIR always have some preparation, yeah, to make something dry. But Raman, as you know, just now they use tap water directly can observe the content of the what is it, running water. So of course, one day if you bring the portable Raman system to the field, so who know this area is very strict, so you cannot bring something go to outside, but you use portable Raman, so you do it directly to use the water without preparation, just pick up the water and then to the Raman system, and you can have some information directly. So therefore, this is kind of the advantages in the future. And also, no, because of the magnification only 1000 times, if we use like microscope, now already designed, so 10 Raman system. So it's mean we can increase the magnification until 200,000 times. I think that's all, yeah. So maybe I will close. Now it's already 11:32. So you will thank you very much for your participation for this session. So we are going to take rest, yeah, to have a break for maybe just 70 minutes, yeah. Next, Professor Gede Karang will continue the other session, yeah, and will be achieved by Professor Gede Karang. Thank you very much for your presentation. See you. So I will close this session. Thank you very much. Bye-bye.
Yes, sir.
Okay.
Bye, sir.
Yes, sir.
I want you to come over. I wish that you would come and give me something to prove. Won't you pull me closer? I think that I'm obsessed with everything that you do. I'm waiting, trying to be patient. You look like a painting. It's so frustrating. I hate it, yeah. I probably shouldn't say this. I probably should erase it. I probably shouldn't say this.